It's me, Miss Shavers. Funny seeing you here. I'm going to talk to you today about square roots. So first of all, let's go over where it got its name. So when we think about a square, that's a square. And let's say this square is 4 feet by 4 feet. Okay, if I was going to find the area of this square, it would be 16 square feet. Okay, and that's what we like to call a perfect square because it's when two whole numbers multiply to get to 16, that number. Okay, so last year you were talking about when you square a number. Well, that's why we call them square roots, because we're working backwards. So when we were doing last year 4 squared, we got 16. Now we're going the opposite direction. So square root of 16 is 4. All right? So like I said, 16 is a perfect square because it's when two whole numbers multiply, the same two whole numbers multiply to get to that perfect square. So other ones include 4, because 2 times 2 equals 4. Then we have 9, because 3 times 3 is 9. Then we have 16, this one we just did, because that's 4 times 4. Then we have 25, which is 5 times 5. So these are all perfect squares, because if we take the square root of them, the two numbers that multiply get that perfect square. The one that a lot of people forget about is 1. 1 is a perfect square, because 1 times 2. 1 times 1 equals 1. So that's also a perfect square. So these perfect squares are going to be important when we get to estimating today. So you're going to have to memorize these perfect squares all the way to 225. And 225 is 15 times 15. So all the perfect squares to 15 times 15, to 15 squared, you're going to have to memorize. So that's where we get square roots from. So now let's take a look at how we estimate square roots. Because, like we went over yesterday, if it's not a perfect square, it's irrational. So what we need to do is estimate where it's at. So square root of 7 is an irrational number. It goes on and on forever, repeats, it doesn't have a pattern, it's irrational. But we're going to estimate it to the nearest tenth, okay? So we're going to think about the perfect squares that it falls in between. So it falls in between the square root of 4 and the square root of 9, okay? Falls in between those. In fact, let's list all the square roots in between those. So we have square root of 5, square root of 6, square root of 7, there it is, square root of 8. So when I think about which whole number it's closest to, if I look at my listed square roots, it's going to be closer to the square root of 9. So let's think about where that would be on a number line. So we go 1, 2, 3, 4, 5. So square root of 7 falls in between 2, because square root of 4 is 2, and 3. So it's going to fall in this section. But if we look at all of our square roots in between, it's going to be closer to 3. It's still in between these two numbers, but it's going to fall a little bit closer to 3. All right? And we're going to figure out even closer the estimate for the square root of 7. So it's in between 2 and 3. So we know that the whole number is going to be 2. All right? We just need to figure out the fraction part. Here's how we do that. So if I draw the square of 4. There it is. So there's 4 as a square. And then I'm going to change it to add on to it so then I get to the square root of 9, or the square of 9. So I add in squares on the sides. And there we get the square root of 9, or square of 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so let's look at the difference between square root of 4, or the square of 4, and the square of 9. So there are an additional 1, 2, 3, 4, 5 squares added on to get from square of 4 to square of 9. So that means that my denominator, I'll write it up here, is going to be 5, because it's 5 additional squares total to get from 4 to 9. how many of those would get to 7? So I'm going to count how far away this 7 is from the 4, how many additional squares that is. So that's 1, 2, 3 additional squares. So I'm going to just shade them in. 1, 2, 3. So that means that it is going to be 2 and 3/5 because it's an additional 3 squares. I'll write it in black. From the square of 4 to the square of 7. So it's approximately 2 3/5. All right, and let's see if that makes sense with our estimate before. So we said before that it was a little bit closer to 3 than 2, and this is a little bit more than half. So that makes sense with our estimate before. The last step that we need to do is just convert it to a decimal. So last year, 3/5 was one of the ones that you had to memorize. So you don't even need to divide the fraction to change it to a decimal. It's already one that you had to memorize. So that means square root of 7 is about 2.6. It's not exactly 2.6, but that's the closest tenth. Let's try one more. There's the visual for it, so then you can see where these fractional pieces are coming from. So let's look at one more. Okay? Let's do the square root of 18. Okay? So I'm going to think about, all right, what's my 2 closest perfect squares? I get square root of 16, and I have my square root of 25. Okay? So this one is 4. This one is 5. So I know that it's going to fall in between there, so it's going to be 4 as my whole number. I just need to figure out that fractional part. So I have square root, I'll just list them out. Square root of 17, square root of 18, there it is. Square root, I guess I should be doing commas, 19, square root of 20, square root of 21, square root of 22, square root 23. Now I'm not, oh, and square root of 24. So I'm not going to draw this one out just because you could see the visual over here. So I got to my 5 by counting the additional squares, but also doing the square root of 9 minus 4 is 5 away. So that's how I got my denominator. So if I look at these two squares are going to be 9 away. Okay, so my denominator is 9, all right? So now I just need to figure out what my numerator is. And remember, that's how far away it is from that first perfect square. So it is 1, 2 away from that first perfect square. So it's approximately 4 2/9. Now I just need to convert that to a decimal, and if we remember from before, we convert fractions to decimals by dividing. So we do 2 divided by 9, and I'll save you a little bit of time. It gets you, because then 18 minus 12, bring down the 0. It gets you 0.2 repeating. So then if I were to estimate it to the next closest, to the nearest tenth, it would be about 4, I'll write it over here, 4.2 or 4.2 repeating. But if I was asking you to round to the nearest tenth, it would be 4.2. Now again, it's not exactly 4.2, but that's the closest estimate we can get. Because remember, that's an irrational number. So that's how you estimate. Please get your practice done and check it over. All right, see you soon. Bye.